Hello students, welcome back to the channel. I am Professor Dhar, and in this video we are diving into a really important concept, iteration. So let's start this video. What is iteration? Iteration means repeating a process or a set of instructions over and over again. In mathematical terms, if we have a function fx and its initial value x0, we can get the values of x1, x2, x3, x4 and so on. So, what is exactly happening here? When you put x0 in the function, you get x1. When you put x1 in the function, then you get x2. When you put x2 in the function, then you get x3. Thus x4, x5 and so on. Now observe carefully. You will find that the next term is increasing by 1 in every case. So what will be the formula? It will be xn plus 1 equals to fxn, where xn plus 1 is the next term and xn is current term. Alright, here's a problem for you. I encourage you to pause the video and give it your best shot. Don't forget, you can find the notes of this lecture in the description to download. Moreover, if you find this video valuable, please consider subscribing to the channel for more content like this. Okay, have you tackled the problem? If you have solved it, fantastic. If not, no worries at all. Let's walk through the solution together. They have given an equation in terms of xn plus 1 and xn, where xn plus 1 is the next term and xn is the current term. The initial value x0 is given and we need to find x1, x2, x3. So what will you do? We will first insert the value of x0 in the given equation. Then we will get the value of x1, which is 1.5. Always use a scientific calculator for calculating this type of equation. Now we will find x2 by putting the value of x1 in the function. In your calculator, input answer instead of 1 and you will get x2. Like this, press the answer button again to get x3. Finally, we have got the values of x1, x2 and x3. A crucial part of iteration is determining a range where our solution likely exists. To illustrate this, let's consider an example. Suppose we have identified that our solution lies somewhere between x is equals to 1 and x is equals to 2. Now we have our equation. Our next step is to substitute these x values into our equation. So when you plug in x equals 1 into the equation, we get a result of -2. Next, we will do the same with x equals 2. Plugging this into our equation, we find that the result is 4. The fact that one result is negative and the other one is positive is a key indicator. It suggests that the actual solution to our equation where the function lies somewhere between 1 and 2. Now let's visualize what this means in a graph. If we look at the graph of our equation, we have just plotted 2 points on it, 1, -2 and 2, 4. Notice how one point is below the x-axis and other point is above the x-axis. If we imagine connecting these 2 points with the curve of our function, the curve must cross the x-axis somewhere between x equals 1 and x equals 2. So it confirms that the solution lies between 1 and 2. Now we will learn to solve a quadratic equation using iteration method. The first part of our task is to find an iteration formula, and the second part is to use this formula to find the solution to 4 decimal places. So, how do we derive an iteration formula? The core idea is to rearrange the equation to isolate x in one side. Here we have to rearrange the formula with respect to x cube, as it's a quadratic equation and its maximum power is 3. Isolate 2x cube, divide both sides of the equation by 2. Finally, to solve the x, take cube root of both sides. Then substitute x n plus 1 in place of x in the left side, and for any x in the right side, substitute xn. This is the iteration formula for the equation. Now, for the second part, we are given an initial guess x0 equals 1. We'll plug this into our iteration formula and keep iterating until our answer converges to 4 decimal places. We will calculate x1 using x0. Using a calculator, we get the result of x1. Now, we use x1 to find x2. Again, we will replace answer in the place of 1 and we will get x2. Then we will calculate x3 using x2. Next, we will calculate x4, x5 and so on. Here, the more we iterate, the more accurate answer we get. At last, we will get a solution which cannot be further iterated. So, that's our final solution. However, as we have to find the solution to 4 decimal places, we can observe that the solution doesn't changes in x4 and x5 to 4 decimal places. Therefore, x5 is our final answer. We can also perform an accuracy test to check the accuracy of our answer. Just put the value of answer in the equation. And we get 5.22 into 10 inverse 4, which is very close to 0. Therefore, our answer is close to accurate. In this section, I have an assignment for you. Solve the question and submit your answer in the comment box. I will provide the answer keys in the lecture slides, which you can download from the description box. Thanks for watching this lecture. If you find this lecture useful, consider like, share and subscribing to get more content like this. So I'm signing off. We'll meet in the next lecture.